But if you want to, you can just say the two pieces over each other here. So we could say x plus 1 over x minus 2, which should equal the piece that corresponds, 12, over the piece that corresponds, x. All right? Remember, if you have plus or minus, you need to group them. So they do need to have parentheses around them, so you remember to distribute. So we're going to say x times this group, x times x plus 1. And then 12 times this group equals 12 times x minus 2. You do have to distribute. So we have x squared plus x equals 12x minus 24. All right. Remember, when you have an x squared, you need everything on one side, and then you're going to have to factor. So for this, we're going to move everything over. I'm going to subtract the 12x over. I'm going to add the 24 over. So that everything over here cancels. X squared does not combine with anything. We have 1 minus 12. And then the 24 also does not combine with anything. And so when we're factoring this, factors of 24 that add up to 11, what are they? 8 and 3. 8 and 3. Yeah, so pay attention to your middle one. Yeah. And if it, honestly, if it's subtraction in the center and addition on the last, they have to multiply to give you a positive 24, and they have to add to give you a negative 11. So x minus 8, x minus 3. You can double check it. If negative 8 times negative 3 equals positive 24, yes. Negative 8 plus negative 3 equals negative 11. Yes, I did my factoring right. All right. Then my next step is to set each one equal to 0. X minus 8 equals 0. So what is x? If x minus 8 equals 0, it's just 8. X minus 3 equals 0. So x is also 3. Since they were both positive, they will both work. Had one of them been negative and it made your length negative, then it would not work. And so then one of them would be excluded. But they both positive, they both work. The way you set it up, as long as you do it corresponding. So if I put this on top, x minus 2, and I put this on bottom, 14. Then when I set the next one up, the corresponding part needs to go along with it. X minus 3 corresponds to the x plus 3. Remember, it is all grouped. So if there's a plus or minus, you need to group it. Which means when I multiply these, I have x minus 2 times x plus 3. On this side, I have 14 times x minus 3. Don't forget the foiling, x squared. I have 3x minus 2x minus 6. Distribute here, 14x minus 42. You do want to combine these. So we're going to have x squared plus x minus 6 equals 14x minus 42. All right. You have to move everything to one side because I do have an x squared. So I'm going to subtract my 14x from my like term. I'm going to add my 42 to my like term. Make sure everything over here cancels. X squared minus 13x plus 36 equals 0. Factors that multiply to give you 36 and add to give you negative 13. Negative 13. Factors that multiply to give you 36 and add to give you 13. Yep, 9 and 4, absolutely. So we have x minus 9, x minus 4. Then I'm going to set each one equal to 0. You'll see they also both work. This is going to give you a 9. This is going to give you a 4. They both work. We have talked about a ton of corresponding parts. They're just adding some to it. So we have some different lengths within our triangles, as well as areas and volumes that create some ratios here. The first theorem we're going to look at is relating to the altitude. Remember, the altitude is perpendicular from the vertex, so perpendicular from one of the vertices. It says the altitudes extending to corresponding sides of similar triangles are in the same ratio. So if you already know your ratio, your similarity ratio between your sides, then you can assume that the altitude has the same ratio. All right, so if you have similar triangles Your similarity ratio applies not only to your sides, it also applies to the altitude, as well as the median. All right, so remember your median goes from a vertex to the midpoint of the opposite side, to the midpoint of the opposite side. So altitudes and medians will be in the same ratio as your side lengths for similar triangles. All right, you can just extend that similarity ratio to those two. Look at this example. Find AD. So first of all, make sure you always know what you're looking for, AD. Given that ABC is similar. Don't forget, this is your similar to triangle XYZ. All right, so find AD. What we really need to pay attention to here is order. Make sure that you can see the orientation is different for these. So make sure that you have the right order. They only gave us one length, so we can probably assume that the lengths are the ones that we should use. But if they had given us all of them, they could have flipped it. So just make sure that you are looking at the right thing. AC should correspond, so A and C should correspond to X and Z. So you just want to double check that you do have corresponding parts here, because you don't want to write them incorrectly. So if I have this, 12 is my first one over the corresponding 8 there. So 12 over the corresponding 8. And that should equal 6. Where's my 6 going to go? Top or bottom here? Bottom. Yeah, it has to correspond to the same triangle I pulled the other one from. So the 8 was on bottom, and that was this triangle. So make sure it goes on bottom here. Something else that I saw is that you switched. Once you started an order on this side, you switched it when you set up your second ratio, and it changes your answer. All right. So yeah, it needs to go on bottom there. We are looking for this, so that is where my variable would be. Remember, you can reduce what goes into 12 and 8. Something bigger can go. Yeah, 2 does. Yeah, 4 goes into it. So we can say 3 over 2. Just make it smaller. X over 6. You can do your cross multiplication if you want to here, or you can just multiply across. But we're going to say 3 times 6 equals 2 times X. So we have 18 equals 2X. So X is going to equal 9. So my answer, since that was what I was looking for, is 9 feet. This is a median. So the picture that we had before was the altitude. It went perpendicular. This is the median. We know that it's the median, even if it doesn't tell us, because we have those marks that indicate those are congruent segments. So we know that's the median, and we can assume that they're both medians and that they have the same ratio. All right, so angle bisectors, if it bisects an angle, they're in the same ratio. Perimeters are in the same ratio. So the distance around is also in the same ratio. So look at the example. It says find the perimeter. We're going to just do perimeter, and then we're going to come back to area. Find the perimeter of this if, and it gives you the first perimeter. All right, so first of all, for perimeter, we know they are in the same exact ratio, So if we look at this, we're going to say, well, what is that ratio? The ratio is going to be 15 over 20. And don't forget, you can reduce it. 5 goes into both of them. All right. The 15 was on top, and that is this TUVW. They gave me the perimeter of TUVW, so that's going to go in my numerator. What we want is the perimeter of the second one, so that's going to go in my denominator. Just make sure you set it up. Again, you're going to do your cross multiplication here. We're going to say 3 times X equals 4 times 66. And you should get that equals 88 if you divide by that 3. So this just told me the perimeter of this one. All right, same ratio for perimeter. Now I want to look at area. Area is slightly different, so that's why I wanted to separate it out. Perimeter is exactly the same. Area is not the same. All right, area is not the same. So let's look at this. The ratio of the areas of similar is equal to the square of the ratio. All right, the square of the ratio. All right, so it's going to be in a different ratio. You're actually going to square it. All right, so this ratio was 3/4. 3/4, all right? So that means that if my ratio of my side lengths is 3/4 for side lengths, in order to find the ratio for the area, you have to square that, all right? So the ratio for this area is going to be 9/16. 9/16. You have to actually square it. And so now when I set up my ratio, 9 is going to be the ratio I'm going to use for this. The area of the smaller one was 216. And so I'm going to use this ratio when I do it. All right. And so when you use your cross multiplication here, you're going to get that x is going to equal 384 square centimeters. Because your volume or your area is squared, so is your ratio. Because what you've done is you've taken that ratio for 2 dimensions. And so you have to square the ratio. You're not going to use the 3/4. You're going to use the 9/16. All right, you actually have to square it. So then let's try some of these. Let's try, and these are all similar ratios, 3, 5, and 11. They want the value of each, the value of each. So just like perimeter is 1 dimension, we have area, which is 2 dimensions. We can also compare volumes, but that is 3 dimensions. So since we took perimeter, that's the same ratio. For area, we squared it, 2 dimensions. For volume, you would cube the ratio. So here, the ratio between those two is 2/5. In order to find the ratio for the volume, you would cube 2/5, which would give you 8/125. And so your volumes would be in a ratio of 8/125 instead of the 2/5 ratio. All right. So look at this example. By what percent should each dimension of a box be increased if a manufacturer desires to produce similar boxes with twice the volume? Twice the volume. All right. So if the volume is exactly double, if the volume is exactly double, then that's going to be whatever the ratio is cubed. Whatever the ratio is cubed. All right, so if the volume of the box doubled, that means the volume is actually 2 times larger. Then how do we find the ratio of the dimensions? Well, they should be the cubed root of the ratio of the volumes. And they just told us the ratio of the volumes was 2, doubled. So this does not, so if I'm going to find it, I'm going to find the cubed root of each side. So r is going to equal the cubed root of 2, which does not have a perfect root. So we are going to just round it. They rounded to 2 decimal places, 1.26. All right. They want this in percentage. So how do I find the percentage? Multiply by what to convert decimal to percentage? 126%. All right, 126%. They're actually asking how much it increases. Increase 100% is just the same exact. So it's actually increasing 20% over its original percentage of 100. So 100 is just the original increase. It went up by 26%. 26%. So in this case, they actually gave us the volume ratio, and they want us the ratio of the original. All right, so they gave us the volume and we backed into it using cubed root. So let's look at an example here. All right, so Ms. Brown plans to enlarge her 5x7 vegetable garden. What are the dimensions of a similarly shaped garden with 9 times the area? 9 times the area. All right? So, figure out what your ratio is for the original, for just the dimensions, and then figure out what your new dimensions would be. What ratio did they give us? Sides, area, or volume? Area, how do you know that? 9 times the area, okay? So they gave us this one, all right? How much did the area increase? By what amount? 9. So they're telling us that this right here is 9, all right? That is what my sides are increasing by squared, right? So this is going to equal the ratio for my sides squared, which means what is the ratio of my sides then? How much should my sides have increased? So if the number squared is 9, then the number must be 3. So all of my sides increase by 3 times in order for my area to increase 9 times. How many times would my volume increase? 27, 3 cubed, right? All right, so in this case, if we wanted to then know the volume, it would increase 27 times. So if every side increases 3 times, how am I going to figure out what my new sides are? Multiply by what? She wants the new sides. So we took the volume ratio, we figured out what my sides are. We need to go back to our original sides. What were my original sides? What by what? 5 feet by 7 feet. My area increased 9 times, but my sides only increased how many times? 3 times. So I'm going to take this and I'm going to multiply by what then? 3. And I'm going to take that and I'm going to multiply by 3. What are my new dimensions? 15 by 21. You can check this, by the way. You can take 5 by 7 and figure out what that area is. And then you can take 15 by 21 and figure out what that area is. And the new area should be 9 times the old area if you did this correctly. Because they told you it increased 9 times, all right? If they wanted how many times it increased volume, you would say the volume would increase 27 times. Let's say they were talking about dirt, filling up the dirt of something, right, to have volume.